Welcome to the week 4 supply chain management video conference. This week we are going to be covering, I'm going to cover rebate effects on demand real quick, just to give an idea, give you some extra information on how rebates influence demand and how you shouldn't use the demand information during a rebate for your forecasting. Very simple. I'm gonna go into demand smoothing in a little bit more detail. I only scratched the surface last week, and I feel that I should give a little bit more detail on this. And I'm gonna do that. I'm gonna go over economic order quantity for this week, and then if I have enough time, I'm gonna go over vendor managed inventory. So without further ado, I'll go ahead and start with the first slide. Rebate effects on demand. We discussed in class how rebates worked and the ethicality of rebates. For instance, is it ethical to use rebates? There were some good arguments. Some people said that arguments exploit consumer behavior, which is a good point, because it encourages you to buy something with the potential of not being able to get the reward in the form of the rebate. Now, to be fair, rebates have gotten better over the years. Like now there's a lot of instant rebates, which I think are okay. But, you can still make the argument that they're not ethical. And some said that they are ethical because at the end of the day, it's up to the customer to go through all the trouble to get the rebate. And as long as the rebate, and some people even mentioned that as long as the rebate is clear, that's fine. But let's see what happens when you use rebates in relation to a product. When you use a rebate, you in essence accelerate the demand of a product in the short term. And sometimes it's okay if you have excess inventory and you understand how much product will be sold during the rebate. Like for instance, if you have 10,000 units and you're able to control the marketing such that you're able to sell 10,000 units, that's fine. Just note that when you sell those 10,000 units immediately, you do two things. One, you get people to buy a product that wouldn't have. That's normal. But you also get people who would have still bought the product but may have waited a little bit of time. This all depends on the product, obviously. But just realize that you actually artificially manipulate the demand such that you'll get a lot more demand in the short term. If you use the demand during a rebate for your forecasting, you're going to induce variation into your forecast. So just keep that in mind as we go forward. So as you see here, the rebates artificially shift the demand left. So people who would have been in the beyond lead time area would have I'm just gonna do some highlighting. So the people who have been in the beyond lead time category over here will now would have moved their consumption to the left to buy it all at once. Which, as I said, if there's a large inventory and you have control over it, that's fine. But just realize that when you do this, that your forecast, if you use this recent information, is going to distort the actual lead time, the actual demand, that'll be used in your forecast. So just keep this in mind when you deal with your rebates and when you deal with your forecasting after a rebate. Now, demand smoothing. Demand smoothing is a strategy that's used as a means to level out the demand to match the capacity of your supply chain. We use incentives to shift the demand to further out so that you either shift it to a low capacity period or to your beyond lead time area. For instance, Boeing uses this a lot. Like when Boeing sells 100 aircraft, they obviously cannot build 100 aircraft immediately. So what they'll do is they'll say, hey, look, we'll they plug the demand into their capacity, and they schedule aircraft manufacturing while giving discounts to airlines based upon how long they're willing to wait for the product. So this is a type of demand smoothing that we use. So this is used in an attempt to maintain a constant flow of products at or below capacity. And that's important to understand. Demand smoothing is a very good strategy that can be used to relieve pressure on your supply chain so that you can either address lead time or increase capacity. Usually when we deal with demand smoothing, we're looking at capacity. We're looking at where your demand is relative to capacity. So last week, I introduced this chart here. So demand versus lead time. This week, I'm going to change it a little bit to make the left hand, instead of the percentage of orders, excuse me, it'll be the number of orders. And then I added a line for capacity. So ideally, you have all your demand below the capacity. In this example, you'll see that your at-once customers, you have more customers than you could service with your supply chain. And even at your lead time period, you still have too many people. So what you can do is we're going to try to shift that to the right. I mentioned this last week. So we're going to shift it to the right. Now, this curve will not always look like this. It's important to remember that. Sometimes you may have a big lump beyond your lead time. So what you would do is you look at your demand anywhere that your expected demand is above the capacity line. That's an important thing. Your graph will not always look like this. And please remember that. Now, as I said, the idea is to move your demand throughout your lead time below your capacity line. Okay, now in this example, we still have people beyond the lead time that is still above capacity. What happens sometimes is you'll get your demand. What I've seen it personally is even if you demand smooth, your marketing team may still do sales that may push your demand above capacity. I've seen one instance where a very industrious manager landed a big sale of electronic systems, which significantly impacted the capacity. And he actually got an award for this. He got an incentive for this, but the supply chain was unable to provide the capacity for the order, and as a result, what ended up happening is they ended up increasing capacity through making people work harder, which is usually not a good idea for the long term. For the short term, it's fine, but in the long term, you're robbing Peter to pay Paul. You accelerate things like wear and tear and morale and burnout, such that in the long term, your ability to maintain that level actually is diminished, and your capacity in the long term is decreased dramatically. So what you would do here is, if you see this forecast, you would go to the customers that are in the beyond lead time and see which of those customers would be interested in various demand smoothing strategies. And I'm going to cover, actually, I'm going to cover that now. So here are some demand smoothing strategies. I've pulled these from like Amazon. Boeing uses some of these. There's probably a lot that I did not list here, but these are the most common ones. When you look at marketing materials, when they talk about demand smoothing, they talk about reducing advertising and marketing. If you have coupons or rebates or incentives, you may want to stop those for a certain period to reduce the demand. If you understand that a lot of your demand is because people have coupons for your product, stop giving the coupons for a certain period so that your demand smoothing comes down, so that your demand comes back to below capacity. In some cases, in instances where your supply chain, where you have orders, in the future, you may not be able to do that. So that may not be feasible from a supply chain standpoint. It just depends on the type of product. So sometimes if you have a short use, high consumption product, reducing the advertisements and marketing can be a very good strategy. Now, offer smaller shipments spread out over longer time. This is good for customers that order large items in bulk and then store it in a warehouse. In the industry that I work in, that's very popular. You'll have, because the way that the government does contracts, they'll give you money for a year so that you can buy materials for the system that you support over that 1 year period. So, and it's you spend it or lose it type scenario. So you may walk up to a company and say, hey, I want 5,000 of these parts to support this system. Well, if you're the manufacturer, you would say, hey, look, we can't give you 5,000 right now, but we know that you don't use 5,000 immediately. So tell you what, why don't we work with you to determine if we can spread those 5,000 over a 12-month period? Maybe we only give you, 500 a month or 400 a month. We may give you 500 a month for the first, 8 months, and then spread out the remainder of the last 4 months. So this is a good incentive, because what this does, this allows a company to lock into a certain price while also not having to worry about storage costs and shipping costs. You could delay the shipping further in the future, and you can encourage people to take this strategy by giving them either discounts over so many items or offering to store the materials. You may say, hey, look, we will guarantee 500 a month for this time, and we will store them and ensure that you have the product when needed. Obviously, your pricing strategy needs to include all these additional costs, but sometimes this is a valid strategy. So offer lowered costs for delayed shipping. Amazon uses this a lot. So let's say you order something on Amazon and they don't have it immediately available. They may say, hey, look, do you have it now? Or we'll give you free shipping if you want to wait 5 to 7 days. In many cases, some people say, you know what, I don't need it right now. I'll just take the discount on the shipping and wait the 5 to 7 days. This is how Amazon demand smooths, using shipping as an incentive to buyers. And then you can also offer a comparable product with a higher capacity as a substitute. Let's say you have 2 comparable product lines, and one product line has very little capacity. You may say, hey, look, we will offer you the same product. Usually it's one that has a higher value. I'm going to be posting something about brands and value proposition. It'll be a product that has a higher value proposition than another product. So as a result, you may encourage someone to take this higher capacity product instead of the product that has a high demand compared to capacity. So that's something you can do. Amazon does this also. Like, for instance, you may look at a route. Like, for instance, recently I bought a router, and the router that I wanted, they said it wasn't immediately available, but on the side it said, hey, here's a router that meets everything you want. It's a newer model, and we're going to sell it to you for less. So I bought the one that was had better specifications and less price. Made sense to me. So, because Amazon probably did not have a lot of the older router in stock, so it made sense to them too. So that's a good demand smoothing strategy that you can use. So for pricing recommendations, this is part of those pricing strategies that you can use in conjunction with your demand smoothing strategy. So reduce lead times as much as possible. Obviously, sometimes you do demand smoothing as a means to smooth out demand in the short term to give you a chance to increase capacity. So you want to both increase capacity and reduce lead times of the products going out. That's important. And what that does is that actually shifts your graph. If I'll go back to this, reducing lead times actually shifts. Sorry about that. So actually, reducing lead times actually shifts your whole graph to the right, so that your beyond lead, more of your beyond lead time customers become at lead time customers. Okay, so your bars will be like this instead of where they were. Okay, that's important to understand. So and of course capacity. When we deal with capacity, we move this bar up. So now you have more products you can do in each of your categories, and you're at once, and you're at lead time customers. You have more people in there, so you have more lead time capacity and more product capacity, if that makes sense. So going back, so that's probably going to be the last time I'm going to talk about demand smoothing. I'm going to try to post something on brand so you understand how value propositions work. So there were some very good comments in the class on brands and how you move, how quality relates to price or anything else. So just some extra stuff to think about as we go forward. Economic order quantity. This is something that we're going to start seeing a lot of starting this week. You're going to be using this a lot in the next 3 to 4 weeks. So I wanted to spend some time to talk about economic order quantity, because this is a very important concept as we move forward. And if you use it, you need to really understand what it's telling you, because the model has a lot of critical assumptions. Now, if some of these assumptions don't apply, it doesn't mean that you just throw the equation away. It just means you're going to have to modify it to take into consideration your assumptions. So, but if these assumptions exist, or if these assumptions are constraints that are acceptable to your calculations, then you may still want to use this EOQ. I personally, when I used to do supply chain work, I would still use EOQ just as a benchmark. So when I was looking at what was coming down the pipe, I'd say, well, my EOQ based upon a perfect forecast or a perfect quantity was this number. How does it compare to a perfect scenario? So I can say, okay, well, the guy's being too aggressive, or the guy's being too safe, or it's acceptable. So that you can, this can be very useful in keeping your management aware of the validity of any order quantities that you create, while using these assumptions in your recommendations to your management. So it says here, it's used to determine optimal purchasing lot size. So basically what the EOQ does, it's the point on your annual costs and holding costs graphs, and you'll be seeing that in a minute, where the total costs and holding costs are equal. That is the point where it's the optimum order quantity. Now, as I said, there's several assumptions that you need to be aware of when you use this. There were 7 that I found. I keep finding new ones all the time. So, but this is a pretty conclusive list, I feel. So your product demand is constant and is known. So we don't deal with variability in this model. The more variability that exists, the more error there is in your EOQ. As I stated in my variation announcement, you'll always have variation of some sort. Just realize that the higher the variation, the harder it's going to be to do your forecasting. Your lead time is known and constant. When you place your EOQ as a retailer, okay, this is used as a retailer. Your lead time is known and constant, so the lead time will never change. Now, in a real world, lead time jumps back and forth. Once again, you want low variability in your lead time. So there's one price per product regardless of how many you order. if there's multiple price points, you're going to have to change the way you do your equation. Takes a little bit of algebra. I've seen over the years people make spreadsheets that do this. Just realize that the EOQ takes into consider one price per product, regardless of the quantity ordered, because we're dealing with ordering costs and holding costs. So if your ordering costs changes, your graph is going to shift right upon the ordering costs. So all units received is a lump sum. So basically, it says that you receive all units at once. If you're the recipient of a demand spending strategy, and you receive them separately, then obviously the holding costs will change. So that's something that's important. So obviously, if you get different pricing based upon how many units you receive, both those graphs will shift. Yeah, both those lines on the graph will shift. So the same quantity ordered at each reorder point. So sometimes you may calculate EOQ for 4 reorder points. So let's say you have four times you order products in a year. EOQ is typically used for yearly, but you can use it for any time period. So if you have 4 reorder points in the year, you just create 4 of these EOQs. You can't just create one to cover all 4. That's important. And the ordering and carrying costs are certain. You know what the ordering and carrying costs are, because that's going to be part of your holding costs. So obviously, if this changes, your holding costs graph will shift. And there's no stock out costs. Stock out costs, I don't know if we've covered this yet, but stock out costs is the cost of having excessive stock. I've also seen stock out costs where it's the cost of not having sufficient stock. So sometimes, let's say if you order too much stock that you can't sell, there's a salvage cost that's involved. So a salvage cost is the cost to you to salvage the sunk cost of a good. So let's say at the end of a season you have 1,000 items, and you can only get rid of you pay $2 per item, and you can only get $1 through overstock.com or closeouts. Your salvage cost would be $1,000 in that scenario. So stock out costs could be if you don't have enough product. It's the loss of revenue from not having this product. But we mainly deal with, in this scenario, if you have too much stock. If you have, because what happens is you have both the cost of the excess of stock that you purchased, but you also have the salvage cost that's factored back in. So realize that your EOQ doesn't really talk to the demand of a product as far as variable demand. Okay. We are going to understand that when you make your EOQ, that your EOQ fits within your demand. Okay. So now, here is the graph. As you can see, your total costs are down here, okay? And this is basically a sum of these two graphs. Your ordering costs start off high and go low. This is because your ordering costs are averaged out over more goods the more you order, okay? The larger the reorder quantity. Okay, then the holding costs obviously start at 0 for no goods, and it goes all the way up to wherever this fits. It's because your holding costs, the more things you have, the more it costs to hold them. In this graph, you can see that the holding cost is linear. In some scenarios, it may be different. Some warehouses might give you a discount for larger and larger things, for larger and larger stocks and inventory. Excuse me. So just keep that in mind. So once again, the total costs are, oops, sorry about that. Total costs is the sum of both of these. And the EOQ is where annual costs and holding costs are equal. And that's the point. In economic graphs, this is the marginal cost. Okay, so the price of one additional good, this is this quote unquote sweet spot to where the price of an additional good is the lowest. So that's your EOQ. Oops, okay. Now let's go ahead and I'm going to clear this. So the calculations that we do for EOQ, you obviously need to, there's three costs that we calculate. The annual material costs, which equals demand times material costs. So obviously, if each item costs $1 to make and you have 1,000 in your demand, your annual material cost in that scenario would be $1,000. Your annual ordering cost is R divided by Q, which is your number of orders per year. The number of orders per year is basically very simple. The annual demand for your product divided by the order quantity. So if your demand is 10,000 and each of your quantities ordered is 1,000, you order it 10 times. Okay, times your ordering costs. So these are the costs associated with each order. This doesn't include the material cost. It's costs associated with ordering the product. So if it costs you $100 to order the products, then in this scenario, you have 10 times you order stuff times your $10 that you pay for ordering the stuff. So it's $100. I think we may have said $100 for ordering costs, in which case it'd be $1,000. You probably get the idea. In annual holding costs is the average inventory level times your holding costs. So this is kind of a trick. When we assume this, we assume that it's a lump sum. So we start off with 0. And your lump sum is 10,000. So you take the average of those two numbers, and that gives you your annual holding costs. Well, your average inventory level. Okay. So if you order 10,000 and you start off with 0, 10,000 divided by 2 is 5,000. Your holding costs is multiplied by that. So you have your annual holding costs, annual ordering costs, annual material costs. This is how you calculate the costs associated with your EOQ. Now, when you do your EOQ calculation is this equation right here. So D is your demand. This is what you determine is your demand for your product. The ordering cost per purchase order is S, and then H is your carrying cost. So straightforward. The textbook provides a pretty good summation. The lecture notes actually do a pretty good job of walking through this. So feel free to use this as a means to understand this. If you have any questions or if I need to go into more detail, put a post out there. I think I have an EOQ announcement that's going to come up during the week to help you understand EOQ. It's a pretty good concept. In my experience, I found that it is not 100% accurate. So you have to put in some of your own assumptions in it and change the model accordingly. But just keep this in mind. The EOQ model is still a useful tool for determining the optimal order quantity. So now the last thing I'm going to cover is VMI. VMI stands for Vendor Managed Inventory. And this is something that has become very popular with the advent of computer systems and ERP, enterprise resource planning systems. You also have MRPs, which is material resource planning. Sometimes I hear it called manufacturing resource planning. They're both valid. In this case, what we do is the vendor controls the entire chain by telling everybody in this chain what they need to do. So in this case, you've got four entities. I've got distribution, warehouse, distributor. Obviously, I got distribution twice. You can put the first block is supposed to be manufacturer. So you have the manufacturer, the warehouse, the distributor, and the retailer. And the vendor, which is the person at the end, the retailer, says basically determines how much product will be in the pipeline at one time. We're going to talk about make-to-stock and make-to-order contracts. So this is a very important concept within this regard, because the type of contracts that you create with these entities is going to determine the ability of the vendor to encourage these groups to place materials in the system. As you can see, this requires a lot of trust on everyone's part. As you can see from the bottom, VMI reduces consumption reporting time. So one of the problems in a normal supply chain is that the feedback gets delayed the more people are in the middle of the feedback chain. If you have to get information from the retailer to manufacturing, in a traditional system, it has to go from the retailer to the distributor to the warehouse to the manufacturer. And each of these things, each of these has bias because each person can change it to fit their own needs. They may do a little bit of panic buying, quote unquote. We're going to talk about this a little bit more in the bullwhip effect as we go in, think like week 8. So just keep that in mind. What this does is this provides an immediate immediate reporting of consumption of the product. Because the vendor, as soon as the vendor gets the consumption data, it's shared with all entities so that all entities will understand. Now, in this scenario, it also, when it's shared, it also comes with a demand from the vendor to meet certain demands. So just keep that in mind. So there are several advantages of VMI, and they're all listed here. So it reduces the number of purchasing, inspection, and storage functions. As I said, the feedback loop is delayed for every leg in the system that gets this information. Well, each of these little entities has purchasing, inspection, and storage functions. We can wipe all that out by basically shortening the distance virtually. Sometimes you'll hear this called a virtual vendor management or a virtual management system. And that's why they say it. So the supplier gets visibility on the rate the product is being consumed. This allows the supplier to better schedule its capacity. It also gives the retailer visibility on the supplier's ability to replenish the stock. In theory, this allows the retailer to see if any problems are on the horizon. Now, in the case of Walmart, as you're going to see, I believe some of the reading during the week we'll talk about Walmart. Walmart uses this as a cudgel to force suppliers into certain performance standards. And in this case, a lot of suppliers do not like that because they don't like to give up control of their own operations. In VMI, the vendor gets a certain level of control over how you perform, how you create your products. So it allows suppliers to prioritize shipments better, which reduces bulk buying tendencies. Demand smoothing strategies work much better for this because you know the entire chain. If everyone works together in a VMI where everyone is an equal partner, this is very good. As you're going to see, it doesn't always work out that way. But nonetheless, if an optimal VMI does that. So, as I mentioned earlier, it virtually shortens the supply chain. And you get frequent communication of all the information that goes through all of the entities. So inventory levels, stock shortages, planned promotions, which allows everyone to increase control over discount levels and their effects. This is important because, once again, if you have delays in your feedback for your forecasting, you introduce variation in your forecasting. And it allows for even more allocation of inventory. Sorry, more even allocation of inventory. In my classes, I always get these arguments about whether or not VMI is a good system for everyone involved. And in the case of Walmart, it especially comes up. Some students say that, yeah, Walmart has a right to beat suppliers into providing certain levels of inventory. Boeing tried this when they did their just-in-time with the 777 when I worked at Boeing, early in the 777's rollout. And Boeing would basically say, yeah, they would force just-in-time, so that basically there was no lead time. They'd say, you know, we want so much product as whenever I order it. But what would happen is the manufacturers, they won't come out and say, hey, I'm going to have problems meeting this demand, because manufacturers keep that information close to the vest. Instead, they will continue to provide the product without giving warning signals that their capacity is being stretched beyond its capacity. So what Boeing suddenly began to see was people that were saying, yeah, I'll give you 1,000 units next month. Yeah, 1,000 units. All of a sudden, we're pumping out low-quality products and eventually weren't able to keep up with demand. So suddenly, they started to see all these problems in their VMI system because they erroneously thought, well, I can see everything. Everyone's working as a team. As long as I tell them what I need, we'll be fine. But in a VMI, you don't have perfect information. You only have the information that's in your ERP or your MRP or that's being reported. So keep that in mind if you're in a VMI. You still need to go through the whole efforts of having a relationship with people. You know, I found that when I was in a quality supply chain role that just talking to suppliers, making them feel comfortable about sharing your information, actually can, in some cases, go further than actually having this big electronic system. So just keep that in mind. A VMI is not perfect, but it's a good tool, though. You know, to be fair, VMI is a very good when everyone. VMI is more effective the more people play on the same page, which leads us to the weaknesses of a VMI. Once again, this is very important. What happens is VMI stresses the relationships between entities within a VMI based upon how aggressively a VMI is used. So in the case of Walmart, you may have distributors, suddenly they'll lose control over their distribution. In some cases, like we've seen, people may feel that distributors are useless. And I've seen in some arguments, some students say, well, why have a distributor? You know, a distributor's role is lessened in a VMI. I was lucky enough in this last conference that I went to bump into a few distributors. And they're part of a distributor coalition out of Texas. And I learned a lot of really interesting things. The bottom line is distributors are starting to change their role based upon what they provide to customers. They no longer just move parts around to customers. They actually have a more integrated role, and VMI is a big reason for this. I'll go into this in a later class. I'm not going to delay this now, but just realize that when you force a VMI on people, people will resist it. For instance, marketing suddenly no longer has the ability to get rewards and incentives for moving certain stock, because now we have better understanding of the demand. You won't have excess inventory for marketing to be encouraged to sell stock. So marketing tends not like VMI because of the incentive structures that marketing works under. So when you use VMI, you need to change the incentive structures for your marketing team. So now, when you run VMI, there is a desire, like within Walmart, to keep inventories low, which is valid. Um, if you have less variation of demand and you have good capacity, you don't need to worry about huge inventories. Well, store owners, especially, if you're Walmart and you know that there's a big season coming up and you don't see a lot of inventory on the shelf, you really trust your suppliers to produce products within a low lead time. So you may have your stores may fear a lack of having enough inventory. So they may bulk order more. They may panic buy, which injects oscillations within your demand in your supply chain. So realize that VMI, although it does work as a very good tool to reduce inventories across the supply chain, human nature can still take effect. And as I said here, distributors lose control over their distribution because the distribution levels are set by the customer, not by the distributor. Distributors are now working with multiple customers now, so they're able to spread their distribution over more items, over more customers, but they still lose control of the distribution. So distributors aren't very comfortable with the system. And inefficient modeling can produce inventory shortages. Like I said before, if you have a model where you think you're going to get a good supply in a short lead time, but you haven't done your due diligence to make sure that your supplier can actually do it, and it's just and isn't just giving you these numbers, you may be setting yourself up for failure. So keep this in mind. With that in mind, this is the last slide. Week 4 is going to be the start of a very difficult part of class. Going forward, there's going to be a lot of work involved. Real quick, one thing, when you do your discussion questions, there's 2 discussion questions on week 4. You must provide 2 responses to each discussion question. That's important. I've seen students only provide 2 across both questions. That does not fulfill your requirements within class. So with any further questions, there's no further questions because I'm the only one here. But if you have any questions, post them in the general discussions or email me directly and I will try to get some answers for you. If I don't know the answer, I will try to get it for you through my various resources. So thank you very much for your time. Thank you for listening to this, and I will see you in class. Thank you.